So my wife, when she's cooking, she always says, no fat, no fun, because fats make foods taste way better than using things that don't have fats in them. However, fats can lead to some health consequences that really aren't good. So we're going to learn a little bit about that today, and I hope you enjoy. In this video lesson, you're going to learn about the fats that, while they're common in many of our foods, aren't really all that healthy for us. At the end of this video, you should be able to describe the structure of fats and the differences between the four types. All right, let's take a look at the structure of fats. All fats have two very distinct components. They have this head region, and then they have these 2 or 3 long tails. Now, the head region has an actual name, and it's basically a small molecule called glycerol. And this glycerol is linked to that tail section, and the molecules that are in that tail section are known as fatty acids. A fatty acid is simply this long hydrocarbon chain. That means that it's a chain of carbons, usually like a dozen or more, and they're linked together with one or more or 2 or so hydrogen atoms, and they're attached to each carbon atom. The fats that are in most of the foods that we eat are called triglycerides. These are fats that have 3 fatty acids, the tail region, so we call it like a 3-tail. That's why the tri is there in the glyceride term. Triglycerides have these 3 fatty acids, and they're linked, of course, to the head section, which is called the glycerol molecule. And for this reason, the terms fat and triglycerides are actually interchanged a lot. Triglycerides that are solid at room temperature are generally called fats, while those that are liquid at room temperature we tend to call oils. Fat molecules contain a lot more stored energy than carbohydrate molecules have, and that is the chemical breakdown of fat molecules releases a lot more energy. So a single gram of a carbohydrate would store around 4 calories of energy, while the same amount of fat actually stores 9 calories. That's not unlike the difference between a $5 bill and a $10 bill. Because fats store so much energy, a strong taste preference for fats over other energy sources has evolved in animals and in humans. Organisms evolving in an environment of uncertain food supply will clearly build the largest surplus by consuming molecules that hold the largest amount of energy in the smallest mass. So this feature actually helped early humans to survive. But today, that puts us in danger from the health risks of obesity now that fats are all too readily available. An important distinction is made between what we call saturated fats and unsaturated fats. These terms basically refer to the hydrocarbon chain in the fatty acid section of the lipid. If each carbon atom in the hydrocarbon chain of a fatty acid is bonded to 2 hydrogen atoms, the fat molecule carries the maximum number of hydrogen atoms and is said to be a saturated fat. Most animal fats, including those found in meats and eggs, are exactly that, saturated fats. They're not essential to our health, and because they accumulate in our bloodstream, they can actually narrow the vessel walls, contributing to heart disease and strokes. All right, so an unsaturated fat is one where some of the carbon atoms are bound to only a single hydrogen, but they're connected to each other, the carbon atoms, by a double bond. Most of the fats that are in plants are unsaturated. So unsaturated fats can come in 2 versions. One is the monounsaturated, and the other one is the polyunsaturated. So a monounsaturated fatty acid hydrocarbon chain, that's a mouthful. Let me say that again. A monounsaturated fatty acid hydrocarbon chain has only 1 pair of neighboring carbon atoms in an unsaturated state, which means it has only 1 double bond. But a polyunsaturated fatty acid hydrocarbon chain actually has more than 1 pair of carbons in an unsaturated state. So that means there's more than 1 double bond. Unsaturated fats are still high in calories, but because they can lower cholesterol, they're generally preferable to saturated fats. In other words, the unsaturated fats are the good fats, and the saturated fats are the bad fats. Foods that are high in unsaturated fats include things like avocados and peanuts and olive oil. And relative to other animals, fish tend to have less saturated fat. The shapes of unsaturated fat molecules and saturated fat molecules are actually different. When saturated, the hydrocarbon tails of the fatty acids all line up pretty straight, and the fat molecules can be packed together very tightly. The tight packing causes the fats, like butter, to be solid at room temperature. When unsaturated, though, the fatty acids have these kinks in the hydrocarbon tails, and the fat molecules can't be packed together as tightly. So, as a result of that, unsaturated fats like canola oil and vegetable oil don't solidify very easily. And at room temperature, they're typically found as a liquid. If you take a look at the ingredient list for most snack foods, almost all of them contain partially hydrogenated vegetable oils. What this means is that in order to hydrogenate an oil, they add hydrogen atoms to the liquid unsaturated fat so that it becomes more saturated. Now, adding hydrogen atoms, what it does is creates a food that has what we would say is a more desirable texture, since increasing a fat's degree of saturation changes its consistency. Basically, what that means is it makes it more solid at room temperatures. And by attaining just the right degree of saturation, it's possible for manufacturers to create foods like chocolate that are near the border of solid and liquid, and they melt in your mouth. Unfortunately, hydrogenation, hard to say a bunch of times over. Unfortunately, hydrogenation will also make food less healthy because saturated fats increase the risk of things like heart disease. They're much less reactive, so our body is less likely to break them down. So when I say they're less reactive, that means they're less likely to react with other molecules. And because our body is less likely to break them down, they're more likely to accumulate in places like our blood vessels. So the hydrogenation of these unsaturated fats that we've been talking about is actually doubly problematic from a health perspective because it also creates something called trans fats. The trans part of the term refers to the unusual orientation of some or even all of the double bonds that remain following the addition of the extra hydrogen atoms. This orientation differs from that in other unsaturated dietary fats. They all have their double bonds in an orientation called cis, C-I-S. Now, trans fats in your diet cause your body to produce more cholesterol, which increases your chance or risk of heart disease. And they also reduce your body's production of a type of cholesterol that actually protects against heart disease. Because there's such a strong link between dietary fats and heart disease, lots of people are trying to reduce their fat intake. A new product that makes this possible is called fake fats. These are basically designed to be similar to fats in terms of taste and texture, but they have one big difference. They can't be digested by humans. One of these fake fats is called olestra, and instead of being a triglyceride fat with 3 fatty acid tails linked to a glycerol molecule, it actually has 8 hydrocarbon fatty acid tails, and it's attached not to a glycerol but to a sucrose. The fatty acids in this octopus-like molecule stimulate the usual taste buds on your tongue, and it tells your brain that you are eating fat. The complex shape of the molecule, though, prevents our body's chemicals, our digestive chemicals, from being able to grab onto it and break it down chemically. And a consequence of that is that it just passes right through your digestive system without being digested. It's not a perfect solution, though. Olestra actually reduces the absorption of some vitamins, which is bad, and in some people it actually causes abdominal cramping.